Our topic is inter-process communication, and the team members are Deepika Modiala, Padmaja Moturi, Surishma Alu, and Kiran Babu Tulimili. We are going to discuss briefly about IPC, methods used in IPC, direct communication, indirect communication, and issues in IPC. A process can be defined as a program in execution. Processes executing concurrently in the operating system may either be independent processes or cooperating processes. The main mechanism of processes is to communicate and synchronize their actions. There are several reasons for providing an environment that allows process cooperation. One of them is information sharing. Since several users may be interested in the same piece of information, an environment to allow concurrent access to such information must be provided. The next reason is computational speed up. If we want a particular task to run faster, we must break it into subtasks, each of which will execute in parallel with the others. Such speed up can be achieved only if the computer has multiple processing elements. The third reason is modularity, which is needed for dividing the system functions into separate processes or threads, and finally for the convenience of use. Cooperating processes require an inter-process communication mechanism that will allow them to exchange data and information. IPC facility provides two operations. One is sending messages, the other one is receiving messages. While sending messages, the message size can be fixed or variable. If P and Q wish to communicate, they need to establish a communication link between them and then implement this link. Implementation of the link can either be a physical process like shared memory and hardware bus or logical implementation. Interprocess communication via kernel space. Basically, all information exchanges involve exchanging data items among the processes. Here, the producers of data items are called senders and the consumers are called receivers. In this, every data item sent by the sender is copied from the sender process address space to the kernel space. From the kernel space, the receiver process copies the data item into its own address space. Data items sent by senders remain in the kernel space until consumed by the receiver. Interprocess communication through address space sharing. In this, a shared memory region is set up among the cooperating processes to allow them to communicate among themselves directly without copying data from the kernel space. Here, the shared memory region resides in the user space and not in the kernel space. From the figure, we can see that there is a common shared memory between the processes P1 and P2. Message passing. Message passing is a general method used for IPC. This provides a mechanism to allow processes to communicate and to synchronize their actions without sharing the same address space. This method is useful for processes inside the same computer or in a distributed system. In both cases, processes may or may not be blocked while sending a message or attempting to receive a message. Examples of IPC in a single computer include pipes, named pipes, and message queues, whereas examples of distributed systems the IPC are TCP/IP sockets, remote procedure calls, and remote method invocation. Hi, this is Padmaja, and I'm going to start with the direct communication. Direct communication is one of the methods for logically implementing a link. Under direct communication, each process that wants to communicate must explicitly name the receiver or sender of the communication. A communication link in this scheme has the following property. A link is established automatically between every pair of processes that want to communicate. The processes need to know only each other's identity to communicate. A link is associated with exactly two processes. Between each pair of processes, there exists exactly one link. The link may be either unidirectional or bidirectional. This scheme exhibits symmetric addressing and asymmetric addressing. And in symmetric addressing, both the sender and the receiver processes must name the other communication, whereas in asymmetric addressing, the sender names the receiver and the receiver is not required to name the sender. The disadvantage of the direct communication is the limited modularity, and also need to know the process name. Indirect communication. Here, the messages are sent and received using mailboxes, ports, and channels. Each mailbox has a unique ID. Process can communicate only if they are sharing the same mailbox. Properties of the communication link. A link is established only if pair of processes share a common mailbox. A link can be associated with more than two processes. Each process can share several communication links, and a link can be both unidirectional or bidirectional. Indirect communication also allows one-to-many, many-to-one, and many-to-many communication. In one-to-many communication, the communication is done between a single mailbox and several processes, whereas in many-to-one, several processes communicate with one receiving process, and in many-to-many, multiple senders requesting service and a pool of receiving servers offering the service. The operations of the indirect communication. There are four main operations of the indirect communication, and they are creation of new mailbox, sending and receiving the messages through the mailbox, attaching and detaching mailbox members, and deleting a mailbox. Send, receive, attach, and detach are the interface primitives for the mailbox MB, and T is the thread which is used. Coming to mailbox sharing, T1, T2, and T3 can share a mailbox A. Suppose if T1 sends, T2 and T3 have previously invoked a receiver at A. Now, who will get the message? Well, the possible solution is type the message with an additional thread ID. Then allow the system to select arbitrarily the receiver. Sender can be notified to which receiver the message has to be delivered. High-level communication patterns often build upon the mailboxes. Now, a mailbox. A mailbox can be private to one pair of sender and receiver. Same mailbox can be shared among several senders and receivers. Port. Port is a mailbox associated with one receiver and multiple senders, and is used for client-server applications. The ownership of port and mailbox. A port is usually owned and created by the receiving processes, whereas the operating system creates a mailbox on behalf of a process which becomes the owner. The port is destroyed when the receiver terminates, whereas the mailbox is destroyed at the owner's request or when the owner terminates. Buffering. Messages exchanged by communicating processes reside in a temporary queue, irrespective of the communication being direct or indirect. Basically, such queues can be implemented in three ways.
Zero capacity. Queue has a maximum length of 0, so the link cannot have any messages waiting in it. In this case, the sender must block until the receiver receives the message. Bounded capacity. Queue has finite length n. At most n messages can reside in it. If the queue is not full when a new message is sent, the message is placed in a queue and the sender can continue execution without waiting. Unbounded capacity. The queue's length is potentially infinite. Thus, any number of messages can wait in it. The sender never blocks.
Hello, I'm Surishma. Now I'm going to discuss why blocking is considered as synchronization. Synchronization is another method used for inter-process communication. It refers to the idea that multiple processes are bound to join up at a certain point in order to reach agreement to a certain sequence of action. It is required when one process must wait for the completion of other process. It is exclusively used in blocking type of message passing. There are two different operations in blocking. They are send and receiver operations. In send operation, the sender is blocked until the receiver reads the corresponding message, whereas in receiver operation, the receiver is blocked until it receives a message from sender. Coming to the properties of synchronization, here processes are tightly synchronized. That means if a sender sends any message to receiver, it cannot send other message until the receiver reads the message. Coming to the next property, effective confirmation of receipt for sender. This means that there should be confirmation to the sender that receiver has read the data. Not more than one message can be outstanding for any process here. The primary advantage of synchronization is that it doesn't have any buffer space problem and it is easy to implement. There are two main drawbacks of this synchronization. One is sender might want to send messages continuously with confirmation from receiver, and the second one is receiver might want to do something else if no message is waiting to be received. Non-blocking is considered as asynchronous. Asynchronous operation refers to the process which is independent of other processes. That means the process which operates independent of other process is asynchronous. There are two types of non-blocking operations. One is non-blocking send and the second one is non-blocking receive. Non-blocking send can send messages continuously. Non-blocking receiver has a receiver that receives valid message or null message. Coming to the properties of asynchronous operation, messages are stored in a buffer until they are received. The amount of buffer space to allocate messages can be problematic sometimes. It is very convenient with no wastage of time. It can increase concurrency. Here, kernel decisions are avoided. For example, whether to swap a waiting process out to disk or not. Coming to the combinations, there are three blocking and non-blocking combinations. First one is blocking send and blocking receive. Here both are blocked until the message is received. The second one is non-blocking send and non-blocking receive. Here both are unblocked. That means the sender can send messages continuously and the receiver can receive. And the third combination is non-blocking send and blocking receive. Here the sender can send messages continuously, but there is a restriction on the receiver. Operating system view versus programming languages view of synchronous communication. Operating system view and PL view can be differentiated based on synchronous and asynchronous send operation. Operating system view. In synchronous send, the sender blocks until the message has been copied from application buffers to kernel buffer. In asynchronous send,
After notifying operating system of the buffer, the sender continues processing. PLVA. In synchronous send, the sender blocks until the message has been received by the receiver, whereas in asynchronous send, the sender carries on with other tasks after sending message. Reliable and ordered communication. Inter-process communication within a computer is always reliable. Hence, it is a reliable communication. For example, TCP, that is Transmission Control Protocol, provides reliable, ordered, and error-checked delivery of a stream of offsets between programs running on computers connected to a local area network. TCP messages are always delivered in order. Hence, it is a reliable communication. Inter-process communication outside the computer, that is the network, is not reliable because the data can be lost here. Hence, it is unreliable communication. Example for unreliable communication is user datagram protocol. Here, there is no guarantee of delivery, ordinary or duplicate protection. UDP messages may not be delivered in same order as they were sent. Streams versus messages. Streams. It is the neutral framework in Unix system for implementing character devices. It is a modular architecture for implementing full duplex input-output between kernel or user space processors and between device drivers. Here, a stream of data is exchanged between sender and receiver. In streams, there are no message boundaries. For example, pipes in Unix and TCP streams. Coming to the messages, here, sender and receiver has the same set of distinct messages. Example of messages are messages queue in Unix, UDP messages or datagrams.
Hi, this is Kiran. I'm going to say the client-server communication today. So, what is a client-server communication? Client-server communication takes place every time whenever you start browsing internet. Here is the process of sharing data from one location to the many other locations. And in this client-server communications, there are mainly three components that takes place. The first one is client. So, what is a client? Consider you are browsing the internet on your computer. So, at present, it's acting as a client. What it does is receive the data from the server or a network to display what are the web page you want on the screen, like that. Which page you want, it will make the display on that. Is the job of the client here. So what the server does? Server holds the data that the client requests, and many clients can access the same information from the same server simultaneously. Here, the web page can be accessed by the several clients. And the third one is the network, and the network allows the communication process to take place between the client and the server. It helps the good communication between the client and the server. And now coming to the pipe. So what is a pipe? Here, pipe is a method of connecting the standard output of one process to the standard input of the another process. Okay, and generally we know that the pipe has two ends. Okay, so when you create a pipe, we will get two endpoints. So yes, it has two endpoints, one end and flows the another end. Okay, and pipes look like a file, and but it's not a pipe, just it looks like a file. And most of us use the pipes quite regularly because it using the shell script programming, and pipes are used to create and visualize it as a pipeline of commands. And it is a temporary connection between two or more single programs, just a temporary connection, and it permits only unidirectional communication. One is the front end and another is the back end. Only unidirectional communication in the pipes. And also, these are the eldest tools of the inter-process communication tools. These generally provide a method of one-way communication between the process, as these are unidirectional communication. And these are used to communicate between two threads in a single process. And it has both parent process and a child process. And come to named pipe. So here, named pipes are generally goes from the FIFO, first in, first out. And these have names and direct links. And name pipes can also be as an endpoint in the Microsoft SQL Server. and these are system persistent and exist beyond the life of the process. Here, Namespice works much like a regular pipe, but they have some noticeable differences. And now, coming to sockets. What is a socket? It's defined as a communication endpoint. Socket is a communication endpoint, and here the sockets provide point-to-point two-way communication between the two processes. And sockets are used for the communication purpose is the major advantage of that. And these are very well structured and the basic force of interprocess and inter-system communication. These socket processes are different types, and here we go over the four types of the sockets. A stream socket, a diagram socket, a sequential packet socket, a raw socket. So what is a stream socket? It provides a two-way reliable flow of data with no record boundaries. And this stream operates like this in telephone communication is an example like that. And a datagram socket, it supports two-way flow of messages. And a sequential packet socket, these also provide a two-way sequential reliable connection for the datagrams of fixed maximum length. Okay? And a raw socket, it provides access to the underlying communication protocols. And sockets can also be used for connection-oriented transactions. So RPC. Sorry. RPC is an inter-process communication that allows the computer program to execute in another address space without the work of any programmer here. And this makes the client-server model more powerful and also easier to program. And it will help for the status of the program because it makes it very easier to develop the programs. And these have multiple levels of application interface: simplified level, top level, intermediate level, expert level, and also the bottom level. And here the RPC technique allows the client and server software to communicate. So it means both client and server helps the software to communicate together. So here, what is the client and what is the server? Client. A process such a program or task that requires a service provided by another program. Here, the client first uses the service, requires service, whatever it wants to service, without having any deal with any about the program. And a server, a process such a program or task that responds to request from the client is called server here. And by considering an example for the RPC, consider client server example here. Even we take a personal database on a remote machine, generally we use Unix for the run a remote shell. In that case, there are some problems here. The command may be slow to execute and you require a login account of the remote machine. So RPC alternative is it will establish a new server on remote machine that will respond to queries whenever you got a query. And it also helps to retrieve information by calling a query, which will be quicker than the previous approach. So it will become more efficient than the previous approach here. So what to do to develop the RPC application means we will have some following steps. So first step is specifying the protocol for the client server communication, and we need to develop the client program and we need to develop the server program for this. So now coming to remote method invocation. So what is RMI? And here RMI is a Java mechanism similar to the RPC, remote procedure calls. And here it shows that is like a mechanism that allows one to invoke a method or an object that exists on another address space. Okay? And that address space could be on the same machine or also different. Okay? Address space may belong to the same machine or maybe different machine. No problem with that. And here we got three processes that participate in the remote method invocation. First one is client. Here, what the client is? The client invokes a method on the remote object here. Next is server. Here, server is a process that owns the remote object here. Server owns the remote object, and the remote object is an ordinary object in the address space here. It's an ordinary object going on here. And the final one is object registry. Here, object registry acts as a name server, and it will deal only with the names here. Okay. Objects are registered with the object registers. Once an object has been registered, one can use object registry to obtain the remote object using only the name of the object. Okay. Irrespective of the other name, only the name depends upon the only name of the object. Here we use two types of classes used in the RML. Is the remote class and the serializable class. What is a remote class? Remote class is one instance can be used remotely, okay, just like a remote. And what serializable class do? Is one whose instances can be copied from one address space to another address space. Thank you.